Alright, hi everyone. So, we have, this is some original number theory problem, and it says you have positive integers a, b, c, d, such that their sum is equal to a minus b squared, and they're like a, b equals c, d, and you want 4c plus 1 to be a square. So, this particular condition, a, b equals c, d, turns out to have a really good way of encoding it. It comes up once in a while. I think not everyone knows about it, but if you're watching this now, you're going to know, which is you let a equals wx, b equals yz, c equals w. I have to decide which way I want the variables. Let's do wz and xy. So this is a nice lemma. Like anytime you have positive integers a, b equals c, d, you can replace them with w, x, y, z like this, and it lets you like kill off the yeah, like if you have a, b equals c, d in a problem like this, I think you just always do this because it's the same reason that when you have an inequality, you like sometimes just, you often, yeah, maybe not often, maybe not always, but you like often just homogenize it, so you just like forget that condition exists. This is exactly what you do, but it's the same thing here, which is like there's no reason you like prefer to work with a, b equals c, d rather than, you know, that. Okay, actually Twitch chat says that using UVXY might be a little cleaner, so okay, why not? Let's use those letters. And if you do this, for example, a plus b plus c plus d actually just factors. It's really great. A equals u plus vx plus y. Meanwhile, a minus b squared, I mean, also factors, right? It's u squared b minus y. So we have. So we're promised that this thing equals this thing, and we want to show that 4c plus 1, like 4v... Really? That's true? Also, wait, I think I'm stupid. A minus b squared. This side is degree 3, so I definitely already messed up. Oh, right, I dropped the square, that's why. Okay. So we want 4c plus 1 and 4d plus 1 to both be squares. And like the condition is just like this is what it is. Like you cannot so actually I'm surprised the problem statement is true. Wait, A goes... Did I flip the order? Oh fuck! I flipped the order. No! No! I'm sorry, I got the order wrong. UY VX. Okay, I'm sorry. 4a minus b squared is u... No, I still messed it up. UV... Wait. This is how you know I didn't get enough sleep yesterday. UXVY VXUY. Okay, that's better, alright? And the A minus B is okay, that's a little more symmetric. Anyway, the factorization I think should still be right, because the factorization doesn't care what the order came in. Okay, so now I have this this thing. And then I want 4vx, 4uy to be squares. Alright, okay, is that equation finally correct now? Okay, great. Yeah, so something that's like, if this equation is true, it should just be true, right? Like there shouldn't be like some very deep reason why this, like I want to say I can just like manipulate it straight out. So u squared, I'm gonna just full expand this, plus v squared y squared minus 2 uvxy should equal. So we'll save 1 ux and then we'll just write everything else out. Wait. I want you. uy vx. Do I want to make vx or uy? It just shouldn't matter. We'll use vx. That will be our target because it's the one with c. So okay. So is this just going to be like ux plus vy? Squared. I'm like trying to complete a square or something. Plus 1/2. I think it should be something like this. Is this true? I think this is true. I might have. Yeah, okay. 2. Alright, I think that's it. No, what? Don't forget to jump. Are you kidding me? Just solve the problem. Alright, I think that's it. Ux minus vy? Did I flip the... Oh, sh... Alright, let me fix that. Wait, what? Hang on. That's actually really bad for me. I want it to be plus. Did I screw something up? Okay, I definitely messed something up. So something's wrong. It's not doing what I wanted to do. Also, I can't. I feel like I can't type anything correctly today. Holy crap. Plus UI. No, I screwed up. This is definitely wrong. I got trigger happy. Like I just feel like it should be something like of this shape though. Like it's like lots of Vietas to jump. Wait, guys. Like, is it not going to just be you do the algebra? Like, I feel like it should just be an identity, but I can't find it. Plus Vx plus Uy. It's asymmetric in C and D. Wait, this problem statement is not symmetric in C and D? How can the problem statement not be symmetric? What? What? Yeah, I agree 4D plus 1 is also supposed to be a square. Why is there a minus sign though? That's so, that just feels wrong to me. Like, uh, 2vx plus a half. It's 2:30 a.m. Thanks for dropping by. I'll try to solve this problem quickly. With probably limited success. Okay, so the thing inside the square. Okay, that sounds reasonable. Okay, let's try that. So you. Okay, so u plus v. Yeah, let's do that. So, we're gonna let s equals u plus v and t denote x plus y. I'm not very good at this algebraic kind of stuff. Sx minus vt. That does seem a little more condensed. Adding 4uxy. Or you think I should just I don't know. Okay, if I add 4uxvy to both sides, you get this. And then you can do the thing that I was trying to do before, which is that this if I add oh god, algebra. So this will blow up a bunch of stuff. And then this becomes uvxy, uvxvy, so you get left with just uy plus vx. I hope. Plus a quarter. Okay, so basically what you're telling me is that it's going to factor, right? Like the left hand side will 2 multiply both sides by 4. This thing now factors 1 plus 4 dx. Okay. So the point is that their product is a square, and I was hoping that they would each individually just be squares from the algebra. I guess it's too optimistic. I might have to actually do some number theory. What do you mean? The GC? Yeah, the GCD. Yeah. Okay. But I want to stress these are all if and only if statements, right? Like, you know, we haven't lost anything so far in this analysis. And if the GCD is 1, then you're set. But I don't think it's obviously always well. Like, I need their GCD to be a square. Like, the claim is that any uvxy which satisfy this equation have a square GCD. Just, well, I mean, no, you need to actually do like some number theory at this point, right? Like, I was hoping it would only be manipulation. You can just bound here? That sounds believable, actually. Well... No, So, if P is a prime that divides both things, then it implies... Like, I need to compare the VPs somehow, which is super annoying. The sum of the left-hand side is... I feel like you're reusing X and Y. I mean... UY VX. Wait. What? Wait. No, like... It's like U is paired with Y on this side, and U is paired with X on this side, right? Like, it's not... This thing is not the average of these two things minus 2. That's just not true. I think I actually need to do, like, pretend to do any amount of number theory. Okay, yeah, I'm just going to write the mod equation to see what happens, alright? Like, suppose... Oops. Suppose P is a prime. Not even necessarily prime. Let's take a prime for now, and I might replace it with a composite modulus later. But like, if there's a non-trivial GCD, in particular, P doesn't divide any of the variables, named variables here. So then we can kill off U, like U is going to be minus like 1 over 4y. And V is going to be minus 1 over 4x P. And so when I look at 2ux plus 2vy minus 1, this modulo P or whatever, this is like minus x over 2y, minus y over 2x, minus 1 mod P. And this is... I think this is clean or something. This is like... x squared... Yeah, it's like x plus y squared, actually. Wait, what? Am I high? Wait, now I'm confused. In particular, P doesn't divide xy. Evan, UV. Wait, am I high? What? No, like it's not true that 1 plus 4c and 1 plus 4d are coprime. Or not 1 plus, yeah. Right? Is it? Wait. I thought someone said earlier that it wasn't true that they are okay, wait. What the What on earth? P divides A and B. So, okay. Why is it a contradiction if P divides A and B? No, you guys are trolling me. Like, you can't. What? Like, what? Am I a stupid head? Yeah, okay, yeah. But like P dividing A minus B squared just tells you A and B are congruent mod P. Like, okay, like here. Yeah, 10th gave you this test case already. Like, test case, A equals 1, B equals 4, C equals D equals 2 is just like a solution, right? Yeah, like, it doesn't do anything. Like. Okay, good. I'm not, yeah, like. Okay, cool. Moving on. Alright, I lost where I was. So, if P divides both this guy and this guy, then unsurprisingly, P divides X plus Y. Well, not unsurprisingly. Like, this implies P divides X plus Y. And therefore, no, it's fine. I mean, yeah, welcome to math. Sorry, I lost my train of thought. I wanted to say that like the VPs are behaving in some way, but I don't actually know how to check it. So if P divides X plus Y, it actually implies what? U and V are negatives mod P. I really didn't want to actually do. I was just like, oh, this is just gonna be out like an identity, right? It's like, nope, they're not. It's not true that. It's not even true. There's yeah. Yeah, I guess that means you can solve it. Yeah. What I really want to have happen, honestly, is I want the two squares to have either the same VP or like P doesn't divide one of them. That would be good enough. I don't know if that's actually true. Feels like it might not be true. Where can I check the problem submissions? You might have to scroll up a lot. Check. They were check like 10 minutes or so in the live vote. Yeah. Yeah, I feel like the fact that this happens to be x plus y squared exactly seems pretty good somehow. In the last yeah, it doesn't really. Okay, you know what? I'm gonna try to brute force my way through this. So rather than doing this stuff with the bot setup, what I'm gonna do is I'm gonna say suppose like, we'll actually introduce notation for the VPs, and we'll say suppose that this is equal to this VP is equal to like something. So S will be some number that's not divisible, T will be some number not divisible by P. So we analyze prime powers. Suppose DE greater than 0 that divide the GCD of the two terms on the left hand side. So, sorry, right hand side. So suppose DE is positive and P doesn't divide ST, then so we take this factorization and I'm going to like basically brute force what the value of 2ux plus 2vy is in terms of these parameters. Because we saw earlier there was this difference, we saw that it was like almost a difference of squares. And I bet I can like kind of just, well, I don't know if this will actually work, but I want to say I feel like I can almost force my way through. So P to the D, so U, if I solve, is -1. Okay, so we get the x minus y squared thing that showed up before, and so that part is fine. Sorry, minus x plus y squared over 2xy, and then we have some terms that are like some powers of. Okay. Periodic analysis strikes again. I think this is it. Because, like, somehow the mods are not doing it for me because the mods are too coarse. I want to actually remember all of the VP information. So, actually, if D and E are even, we are okay. D plus E is even. Assume for let me set it this way. My prime powers. Choose any prime P, and suppose this is true for P not dividing S and T. So this means E equals VP 1 plus 4Vx. Then D plus, so assume for contradiction that D and E are odd. That's the thing that we think is probably not going to happen. Shiba. S and T aren't necessarily squares. That's not. Wait, oh, this is something else now. What just happened? Yeah. This actually looks pretty bad. So odd, in particular non-zero. So the VP of this entire expression is supposed to be equal to the average of D and E. I bet that's... not going... So accent? No. Yeah. We can assume we're log GCD ST equals 1. Seems... So all of S, X, Y, and whatever are non-divisible by like I feel like I'm worried about this case where D and E are equal to each other, in which case like I don't know. Well, I don't know what's going on actually. So if D and E are odd and different, then I actually do get a contradiction right away. Because what happens is if D is strictly less than E, for example, then this is even valuation, this is some odd valuation D, this is some odd valuation... Wait. Oh shit. Hang on. No. How do valuations work? You always take the smallest one, right? Yeah. Oh, this is such a weird argument. How is it free if D equals E? The thing is, if D equals E, then like this sum could be either thing. So I need some statement that says x plus y squared. Like this is some even number. This is some odd valuation number. But if it's the same odd valuation number, their sum could have any valuation, right? Like, if D equals E, I think what I need is I need a claim that, like, S times x over 2y plus y t times y over 2x is, like... divisible by... So you can chase work out. It works out? No, how does it work out? It'd be kind of silly if it didn't. I mean, I believe you, but I don't. So okay. Let me write this out, all right? So if d less than e, say, then the valuations of these three terms are the VPs of these three terms are in some even number D and E. If k less than D less than E, then the total valuation is k, while if D less than K less than E, the total valuation is the VP of the sum equal D plus E over 2. Yeah, but like I'm having problem with this D equals E case, alright? Which is actually the case that we do care about, because that case does actually show up. If D equals E, what I want is I need to instead show that I claim that what happens with D equals E? Which is odd. Yeah, and what's wrong with that? Why is that a contradiction? Oh, K doesn't matter, because K is even, right? So that's okay. Like, so if K is strictly less than D equals E, we're also okay. Consider the sum. Well, let me just give this sum a name at this point. Then VPS is K. Consider cases. Well, then D equals E equals even? Why? The K less than it is impossible for the total sum to be D equals E since K is even. Why? Either size issues or parity issues. What? Okay, so if K is strictly less than D equals E, then VPS is still equal to K, which is less than. But if like what if K is what if shit I left out a. Like, what if K is just bigger than D and E? Like, what do you do then? What do you mean we get size issues? What's a size issue? Okay, cool. Okay. Like, I really want s times x over 2y. Like, I think this thing plus this thing, like s times x over 2y plus t times y over 2x, like, should actually be a multiple of p in that case too. But I don't know how to prove it. Like, oh, actually, no, I think I know how to prove it. So, from DE being greater than 0, we know that, so, that's positive. In particular, we know that, 1 equals 4uy Vx is congruent to minus 1/4 mod p. We deduce, so we also know that x is congruent to y mod p, x is congruent to negative y mod p. In that case, s times we get, this is so weird. I don't think I've, like, I know that these are techniques that I should know, but it's been a really long time since I've had to do a VP analysis this deep. Like, even like that, this is like the deepest VP analysis I've done on like a competition problem in a really, really long time. X over. Wait, no. Did I think I've screwed up the factors. No, I did the VP analysis for that China TST 2018 problem you're talking about, which is a required problem in the VP unit, is a lot less deep than this. Okay, I'm like doing like, it's not close. Like that one just requires you to like have enough common sense to use Dirichlet theorem. Like this is actually VP analysis. Like this is what VP analysis I thought would look like, this is like what VP analysis feels like it should look like if you're really using the whole power. But I've very rarely seen this much power used. I give up on VP analysis before I get half as far as heaven here. I mean, can't blame you there. Like what I was trying to do is like add these two equations and try to like Yeah, like I really need this thing to add, like these two rightmost terms to add. Because if these don't stack to, if this thing plus this thing doesn't stack, I think I'm screwed. I think I'm actually just screwed. Um, but it feels weird because I feel like I'm going in a circle. Where I was trying to use, I'm trying to use this x plus y thing like a second time. Uh... I get I am getting the sense that this is not the intended solution, but I feel like does this not? Like this should, like, okay, basically what's happening is that we know that this is like we know this sum is actually divisible by, oh, that, sorry, oh, I don't, what am I smoking? No. Hang on. Hang on. Like, I feel like from the fact that x and y are negatives modulo p, like s and t should be negatives mod p. That's really what I want. So we already know that x and y are negatives mod p. That much is true. Just true. Like I want specifically s and t to be negatives as well. I think this should just be true somehow. So how did we get that? Because we did this before earlier. What did we do to get that? Oh. Shit, are you actually serious? Oh no. 1, 1, minus 1, minus 1. What is that in UVXY notation? Thank you, Balls. Thank you, Balls Function 1 for the follow. Okay, I'm just gonna... Like, I feel like this is supposed to work. I know that you guys have an idea with this, some discriminant of some quadratic, but I feel like this is supposed to work. I just can't force it. Like, I know that u, y, and vx... Wait, before we got x plus y... Am I just being stubborn? Is this, like, not gonna work? I feel like it has to work. I really don't want to use it. X and Y are the same. I agree. X and Y are the same mod P to the D. That's what I'm... Yeah. Yeah, in fact, I can... Or wait, actually, let me double check that. Yeah. Or, hang on, no. Like, D halves-ish? So, like, K is bigger than D and E. No, K, if K equals 0, you're gonna die. That case doesn't matter. Wait, if this is true, then K equals 0. Wait, what? Ux plus 2vy. X and Y should be negative smosh. Yeah, I agree. Yeah. 2ux plus 2vy, also 2x plus 2vy equals 2xu minus v. How are you getting 2ux plus 2vy equals 2xu minus v? Can you, because p to the d divides x plus y, right? What? Okay, alright. Wow. Like it has like it just, I don't know. It feels like it has to be a multiple of p somehow, but I can't prove it. Why do I need this? Like, do I just add these two things? Okay, so when I add these two things, and I'm actually just out of board space, amazingly. So we're gonna move everything over. Done. Like I guess so 2s plus p to the d in the case d equals e less than k, like p to the e times s plus t plus twice s. So we're worried about the case that this is also a multiple of v, but u plus vx plus y, right? Times 4 or whatever. This is like 0 mod p to the e. Or something like this. Okay, so assume k is less than d equals e, but for contradiction, that vp of s is equal exactly to just d. Yeah, so we have this thing. On the other hand, k is, we know that p to the e divides x plus y. X plus y all squared. So like p to the ceiling e over 2 divides x plus y. Then p to the ceiling of e over 2 also divides u plus v, since u is congruent to negative 1 over 4 y modulo p to the e, and so consequently, hence p to the e plus 1 divides u plus vx plus y. Okay, forget that this is 0 mod. So hence p to the e divides u. Okay, so that happened, and then thus 2s hence this can, so this can, okay, there we go. So we assumed for contradiction that s had exactly vp equal to I keep using e, so I'll use e. Then this thing and this thing added to something with strictly greater valuation. Therefore, these two things had the same valuation. Vp of 2s equals Vp of p to the e s plus t. Let me switch the order of these two terms. Okay, and hence, wait, this is the opposite of what I wanted to prove. I wanted to show that s and t were distinct modulo. Wait, hang on, what? Wait, this is the opposite of what I wanted to prove. I think I proved that I'm screwed. Wait, no, really? I even got the ceiling in. Wait, I did this and I proved that I must be in the bad case? That doesn't sound right. I finally got control of s plus t. And I've showed it's not, but x is congruent to y modulo p. Wait, what? How did I land in the bad case? That's not what's supposed to happen. Oh, god damn it. No! Are you? Sheepa. That's very sad, actually. Okay. Damn, I was actually really confident that this was gonna work. But if I landed in this case, that probably means I can construct a counterexample. Like, I want a counterexample to the claim that these are not VP consistent equations. So I guess like. Really? I really thought that this like ceiling thing was going to be the final push. Alright, I totally got baited. Really? Because I was like, I finally managed to use the fact that it was odd a second time. And then like... Wait, also, I think I'm stupid. No, never mind. No, x plus y, yeah. So u plus v, x plus y. So u and v are the same. What did I say I wanted before? I wanted s plus t, but I'm getting like s is equal to t. Are you guys sure I didn't flip a sign somewhere? Like, here, it's s plus t? Okay, because I have these two equations, right? Like that no, that's not quite good enough. No, it should be actually. So like this equation like p to the e halves divides x plus y. So like x and y are negatives, and then u and v are also negative. U and V are also negatives. No, I don't think that the a equals b equals -1 counterexample doesn't actually do anything for us, because I think that corresponds to like some of the variables being 0 somewhere. Where, in which case VP analysis doesn't work if like there's zeros floating around. Or actually, okay, what is... For the a equals b equals -1 and c equals d equals 1 counterexample, what are the values of u and v that you get? Like -1, like, so u equals v equals -1 and x equals y equals 1. Oh, yeah, that does seem to be. And then what is s in that case? No, sorry, it's like u equals -1, v equals -1, x equals y. No. Shit. -1. Sorry, -1, 1, 1, -1. Okay, fuck. And then you get 3, 3. This is -3. Oh shit. Okay, yeah, you guys are right. All right, sorry. I thought that. Alright, and that's why the VP analysis doesn't work. And cannot work. Why is AOPS online showing in this over? What? Hang on. That's not supposed to happen. How? What? Okay, I don't know what these things are, but they're not supposed to be there. How? Okay, I don't. If you want to see the one-liner. Yeah, alright, this is why it's not working. It's not actually true. This is such, like, I feel like you should be able to, okay, whatever. Okay, so that means I just throw away all this stuff for the last couple pages. And now we're back at this equation. Okay, so someone had a quadratic earlier. What was the idea for the quadratic? So the idea, I guess, was that I should instead. I should be wait. S equals u plus v x plus y. So I'm not even using the square factorization. The claim is that I should just go directly to what? Okay, so the claim about the quadratic that I kept ignoring in favor of VP earlier is that starting from the equation u plus vx plus y, thank you Dr. Dotson for the follow. We're going to define S and T to be the two sums, which will tacitly assume are non-zero, otherwise the other counterexample that we had earlier will kill us. And then rather than like keep the symmetry, the idea is that we're going to use x and v. Then the given equation becomes st Is this better to work with? So this one is actually homogeneous in S and T now that it's written this way. What is the like eventual end goal? I want what is 4c+1 in this notation? c+1 is equal to, so 4c was equal to vx. That's actually good for us. Oh wait, yeah, that's actually good for us. We don't need to, it doesn't even involve SNT. So without loss of generality, GCD ST equals 1. Because we can scale out any common factors. Then we can we're gonna run out of letters. I'm trying to avoid P and Q. Frick. Can I? Or we'll use alpha and beta so I don't have to use S and T. Then we can let m equal alpha equals m squared, beta equals n squared, and write instead xm squared minus y vn squared is equal to mn. Again, target is still to show 4xv plus 1 is a square. Oh, sorry, this is plus minus mn. I mean, it doesn't really matter. In fact, like, oh, I'll just keep the plus minus sign in there. I don't think it's supposed to matter. Okay, now do people want to Vienna jump? Because we can try Vienna jumping now. This looks like the kind of thing that Vienna jumping is made for. I'm so pissed the VP didn't work. You're telling me I have to Vienna jump instead? Oh frick! It's actually a quadratic. No, it's actually a quadratic. Okay, yeah, this substitution is good. I think that's a TLDR. I should have done this before. I didn't realize it would be this not clean. Because now you have that this is actually like this is like textbook Vienna jumping. What's gonna happen is probably for the problem is I actually hate doing this Vienna jump thing, so I don't actually know how it goes. But if you hold fix the solution for n, you can flip the solution for m. Actually, no, never mind. I'm stupid. Ignore everything I just said. We can just use the rational root theorem. I see. That's what you were talking about earlier. I'm sorry I didn't catch on. The point is that this thing has a rational solution. So, in particular, the quadratic equation. Now I need like another variable. What is a? What letter do I use? Guys, I need a letter that looks like it's a real number or something. And so M, N, no, I'm not using how. We're just gonna use theta. Screw this. Has a rational solution, therefore the discriminant 1 mp1 squared minus 4vx equals 1 plus 4vx is a perfect square as desired. Which, okay, like, oh, sorry. No, what? No, that's not how the discriminant of a quadratic works. The discriminant is like b squared minus 4ac or whatever, right? Like, it's this thing. There's no m squared n squared. Like, no, oh, well, I mean, what's your quadratic? Like my quadratic is this. I don't know what your quadratic is. Like, if you want to scale all the coefficients so that it has an integer solution, I mean, that's okay, but, if you look in terms of m, I guess. Anyways, alright. Okay, I guess. I don't. Why do you? Where does this substitute? Yeah, somehow that alpha beta substitution is really important. I guess because you need those variables to not be 0, because the problem statement is false when u plus v or x plus y is 0. I don't know if you can see this from the VP side. Like, I have u plus v x plus y in here. Like, I am actually using alpha and beta. But somehow, like, this deepen... You know, I am not convinced this is a counter... Sorry, I'm actually not convinced this counterexample shows VP can't work, because it causes this thing where... Well, okay, no, it breaks the statement that there's a VP issue here. But, like, somehow this idea seems like it should be doing something anyways, because it's catching on to the case that something goes wrong. Which is when either of these things is 0. I don't know, maybe I'll think about it more later. Yeah, I don't know. I just like VP, okay? I was really excited, I'm like, wow, this is gonna be like, you know, actually a VP argument instead of the really boring kind, but no, not such luck. Okay, whatever. Anyways, good job, Twitch chat. The alpha beta thing turned out to be the most important step. I'm just not good with expressions, so I don't think I would have caught that. Yeah, well, that's why I was excited. I wanted a VP problem that was like actually like a long VP, like not even like as long as this, just like more than 2 steps. Fucking stupid. Anyways, alright, let's get this in. Alright. Dude. I'm actually so sad right now. Also, now that I've done this I feel like this problem is like, I would have wanted to put this on like an Otis practice exam, but I just streamed this solution, so I think that probably means that it'll be a few years before I can use it. Alright, okay, I want to see if this thing works. Let me try something, alright? No. The product condition implies that... No, never mind. No. Hang on. I didn't set this up yet. Actually... Okay, let's see if that works. The product condition implies... No, fuck. I should have checked this beforehand. What? Permission didn't... Oh. Okay, I understand. Yeah, I set up a dictation thing on this on my box a little while ago, so I wanted to see if I could get it to work. But actually, I think I know what the issue is. Let's see. This assumes it's a one-user system. I'm sorry, this is completely like not useful right now, but what do you mean failed to set up term? The product condition implies that paragraph stop now. Okay. Yeah, it's kind of working. I think I didn't set up the... Did I not set the stop now sequence? It doesn't matter. Is voice to text allowed at IMO? I don't... Last I checked, computers weren't allowed at IMO, period. So... Like, I guess not? Okay, and then we're gonna copy paste the actual solution and not all this garbage we did. Yeah, I'm gonna avoid the scaling language because it's a little confusing. Okay, cool. Will I ever post the IMO 2023 modes? Maybe eventually. It's just not very high on my priority list because, in particular, I haven't kept up with a lot of like the recent IMO stuff. So I don't like I don't know how to rate problem 6, for example, because I was spoiled on the problem and didn't get a chance to try it myself. For any positive integer k, comma, an example of a satisfying quadruple is paragraph stop now. Okay, the stop now command is not working. I'm not sure why. I'll debug that later. Image or A, B, C, D equals, well, what did we say the example was? Like k squared, k plus 1 squared, k plus 1, k plus 1, which corresponds to yeah, it's still, yeah, I'm just trying it out just out of curiosity. I think it only makes sense for long paragraphs that don't have math symbols in them right now. Okay, UVXY in this notation are what? K. Oops. And then when I do this, am I getting this right? It's like I'm not very good at this kind of thing, so I tend to mess it up a lot. Yeah, I already screwed up. It's like k plus 1, k plus 1, right? UX is VY, VX, VY. And then these are both equal to 2k plus 1. And then m equals n equals 1. Which is, yeah, which is what we want, because we want, could equal 0. alpha beta equaling 0. It's only alpha equals beta equals 0. No, actually no, that's not true. Whatever. We'll just leave it at that. Alright, fine. What do I label this? I have no idea how this problem was written, but apparently it happened. Where'd the URL for the problem go? Someone posted it a moment ago, but I can't find it anymore. Did I close it? I probably closed it. Okay. Alright, substitute D equals AB over C. Wait, what? That works? The heck is this? Okay, wow, that is a solution you could have. All right. Okay, yeah, that works. Yeah, let's do something else. I think oh, what do I think about a different problem now? Also, what the